Students, in last video we discussed about vector calculus most expected questions. Now in this video we are discussing some most expected bits from these electrostatics topics. See here the first question, a point charge of 10 power minus 9 coulombs is placed at a point A in the free space. The potential difference between the 2 points 20 centimeter and 10 centimeter away from the charge at A will be. This is the question. See here students, a charge is given here, a charge, what is the value is given? 10 power minus 9 coulombs. This is the charge value. The charge is placed at a point A in free space. Then is asking the potential difference between the 2 points. I am considering 2 points here. One is A, another is B, where A is 20 centimeter, A is at a 20 centimeter and B is at 10 centimeter away from the charge. This is I am considering charge from this charge to point A 20 centimeter and from this charge here I am writing 10 centimeter. This is the question. Then is asking what is the potential. See here we know that potential formula due to point charge, that is V equals to Q by 4 pi epsilon naught R. I am writing an epsilon naught because he is mentioned the medium is free space. So Q by 4 pi epsilon naught R volts. V equal to Q by 4 pi epsilon naught R volts. So that equals to I am writing 1 by 4 pi epsilon naught, value everyone knows, 9 into 10 power 9. You must remember in this chapter 1 by 4 pi epsilon naught value is 9 into 10 power 9 and charge value is given as 10 power minus 9. So I am substituting all the given data here. V equals to charge 10 power minus 9, 1 by 4 pi epsilon naught, I am writing 9 into 10 power 9, 9 into 10 power 9, at 2 points is given, I am writing here 1 by 10 centimeter is given, I am converting into meters, 10 power minus 2, minus 1 by 20 into 10 power minus 2, because the distances are given in centimeters, we are converting into meters. Then see here 9 into 10 power 9, this 10 power 9, 10 power 9 cancel here, potential V equals to 9 into, I am writing here 9, 1 by 10 minus 1 by 20, 1 by 10 into 1 by 20 into 100. So that equals to 9 into 20 minus 10, LCM 20 into 10 and here I am writing 100. So 20 into 10 that is 200, 100 1 ja, 100 2 ja, next to this becomes 10, 2 1 ja 2, 2 5 ja 10, that equals to 45 volts is the answer. 45 volts is the answer. So here he asked potential due to a point charge and he asked potential value at 2 different points. So according to superposition theorem or direct formula, here we consider formula potential V equal to Q by 4 pi epsilon naught R, then the answer is 45 volts. This is the answer. Option 2 is the correct answer. Next question, here we are discussing. The question is a potential field is given by V equal to 3x square y minus yz. So here potential is given, the potential is a scalar quantity and here the potential is given in rectangular coordinate system. So what is the potential value is given here? V is equals to 3x square y, 3x square y minus yz, 3x square y minus yz, this is the potential. Then is asking the electric field, is asking electric field at 1 comma 0 comma minus 1. So when potential is given, how to find electric field means there is a relation between E and V, that is E equals to minus del V. The negative potential gradient is known as electric field intensity. Here potential is given in rectangular coordinate system, hence we are using potential formula in rectangular, that means gradient formula I am writing in rectangular coordinate system. So what is gradient formula in rectangular coordinate system? That is, I am writing minus dou V by dou x Ax cap plus dou V by dou y Ay cap plus dou V by dou z Az cap. This is potential formula in rectangular coordinate system. Now what is the potential value is given here? V equal to 3x square y minus yz. I am substituting everywhere here. See here. Then that equals to minus dou by dou x of 3x square y minus yz Ax cap plus dou by dou y of 3x square y minus yz Ay cap plus dou by dou z of 3x square y minus yz Az cap. Here I substituted V value everywhere. The first term I am differentiating with respect to x. Then what is the value here? 3x square y, that become as 6xy Ax cap plus I am differentiating with respect to y, then it is 3x square minus z Ay cap. Now I am differentiating with respect to z. First term there is no z, that is minus y Az cap. This is electric field intensity in vector form. But is asking here electric field intensity at 1 comma 0 comma 1 is given one point, 1 comma 0 comma minus 1. That means what? X equal to 1, y equal to 0, and here z equal to minus 1. Then here what happens here? X equal to 1 but y value 0. So first term become as 0 Ax cap. Second term 3x square, that is 3 minus of minus plus 1 Ay cap and plus minus 1. So that is also y value 0. So I am writing here 0 Az cap. So simply here answer is 4 Ay cap. That is the simplification. But here formula, here minus sign is there. I am writing here everywhere minus sign here. So minus sign is there because here answer electric field E equals to minus 4 Ay cap is the answer. So what is the answer here? Electric field E equals to minus 4 Ay cap is the answer. So here you identify what is the input, scalar, vector, first thing, whether it is scalar or vector. Then after that what is asking, whether it is scalar or vector. Then find the relation between input and output. Here potential is given, he is asking electric field intensity. The relation between electric field and potential is E equal to minus del V. Here potential is given in rectangular coordinate system, hence I am using gradient formula in rectangular coordinate system. Then finally what is the answer? Minus 4 Ay cap volts per meter. So from our options, option 3 is the correct answer. Next we are discussing one more question. The question is, what is the volume charge density at a point 1 comma 2 comma 1 associated with electric flux field D is given. D equal to y square Ax cap plus yx square Ay cap plus z Az cap coulombs per meter square. This question is related to Maxwell equation, which is also known as divergence theorem, which is also known as Gaussian theorem. So here what is the input is given? First here electric flux density is given d bar. Electric flux density d bar is given as xy square ax cap, xy square ax cap plus yx square ay cap plus zaz cap coulombs per meter square. D is given as xy square ax cap plus yx square ay cap plus zaz cap coulombs per meter square. Then is asking what? He is asking volume charge density, that means rho v. Where is asking? At a point is asking 1 comma 2 comma 1, how much? What is the volume charge density at 1 comma 2 comma 1? So from Maxwell's first equation or Gauss law in differential form, the formula here we required is divergence of D equals to rho v. This is the formula we require here, divergence of D equals to rho v. See students, here the given input, that is a dielectric flux density, is given in rectangular coordinate system. In rectangular coordinate system, so I am writing divergence formula in rectangular coordinate system. Divergence of D equals to, I am writing here, dou by dou x of dx. What is the meaning of dx here? Magnitude of flux density along x direction plus dou by dou y of dy. Dou by dou y of dy means what? dy means magnitude of electric flux density along y direction plus dou by dou z of dz. Dou by dou z of dz. What is the meaning of dz here? This is also magnitude of electric flux density along z direction. So from the given equation, first you identify what is dx, what is dy, what is dz. Here xy square is dx, yx square is dy and z is dz. So identify the magnitudes of flux density along x direction, y direction, z direction. Now I am substituting. See here, divergence of D equals to dou by dou x of dx xy square plus dou by dou y of dy, that is yx square plus dou by dou z of z. I am writing here. See here, I am differentiating first with respect to x, then it is y square. Next I am differentiating with respect to y, that is x square. Finally I am differentiating with respect to z, that is 1. This is the divergence of D, rho v, but is asking the volume charge density value at a particular point 1 comma 2 comma 1. So I am writing here divergence of D means rho v, where is asking at 1 comma 2 comma 1, that means x equal to 1, y equal to 2, z equal to 1. So I am writing here y value 2 whole square, x value 1 plus 1, 2 square becomes 4 plus 1 plus 1, that equal to 6. So volume charge density units coulombs per meter cube. So answer is 6 coulombs per meter cube. Option 1 is the correct answer. Next question here we are discussing. The question is given that D equal to 10x ax cap coulombs per meter square. Determine the flux crossing a 1 meter square area that is normal to the x-axis at x equal to 3 meters. This is the question. So here what is the data given? First we will check. Electric flux density is given, that is given in rectangular coordinate system. D bar equal to 10x ax cap. D bar is given as 10x ax cap. What is the units? Coulombs per meter square. He is asking the electric flux is asking. So I am writing here electric flux symbol is psi. psi equal to how much is asking, and he mentioned one condition, the flux lines crossing a 1 meter square area. So area value is given. What is the area value is given here? 1 meter square. Area is given 1 meter square area. That surface is normal to the x axis at x equal to 3 meters. So students, we know that the relation between electric flux and electric flux density. What is the relation? Psi is equals to surface integral of d dot ds. This is the relation between electric flux and electric flux density. Psi is electric flux, d is electric flux density, coulombs per meter square, differential normal surface vector, units meter square, coulombs per meter square into meter square. What is that one? Coulombs. So this is electric flux formula. Psi equal to surface integral d dot ds. Now see here, I am substituting the given data, but before that he is given one condition that area is normal to the y-axis. If I consider this figure, see here, this is x-axis, y-axis, z-axis. I am considering here orthogonal coordinate system. So when it is normal to x-axis means that area is on YZ plane. Where is that area? That area is on YZ plane. When it is on YZ plane, then only it is normal to x-axis. So from this condition, I am writing differential normal surface vector ds bar equal to dy dz ax cap, which is normal to x-axis. Dy dz ax cap. Now I am finding electric flux psi equals to surface integral of d value. What is the d value given? 10x x cap dot ds bar dy dz ax cap. According to dot rule, ax cap dot ax cap equal to 1. That equals to, I am writing double integral 10x dy dx. Observe carefully here, because excuse me, because in this condition the range of yz is not given. The range is not given, but is given indirectly. Double integral of dy dz, what it indicates? Area. Given area value how much? 1 meter square. So I am writing this value now, 10 into x value is given 3, double integral dx dy value 1. So answer 30 coulombs. Electric flux units how much? Coulombs. 30 coulombs is the answer. So from that options, option 1 is the correct answer. One more question here we are discussing in electrostatics. A charge is distributed on x-axis. So I am considering this is x-axis. A charge is distributed. So to identify, so this is x-axis, this is y-axis, this is z-axis. A charge is distributed on x-axis. I am representing like this. A charge is distributed on x-axis having line charge density. Line charge density value is given rho L, that equal to is given 6x square micro coulombs per meter. Micro means what? 10 power minus 6. Then is asking the total charge over the length of 10 meters is asking. So students, the total charge due to line charge density formula everyone knows. Total Q total equal to, I am writing integral of line integral of rho L dl. Line integral of rho L dl. From here I am writing that equals to line integral of what is rho L? 6x square micro, that is 10 power minus 6, and the charge is distributed along x axis. So I am writing here x, and what is the limits? x equal to 0 to 10 meters. X equal to 0 to 10 meters is given. So from this total charge Q total equal to I am finding 6 into 10 power minus 6, I am writing constant, integral x equal to 0 to 10 x square dx, that equals to I am doing 6 into 10 power minus 6 integration of x square dx, that is x cube by 3. What are the limits? 0 to 10. So 3 1 ja 3, 3 2 ja 6, 2 into 10 power minus 6, upper limit 10 power 3. So that equals to 2000 microcoulombs. Is there any answer? 2000 microcoulombs. Otherwise 2 millicoulombs. Yes, that equals to rating 2 millicoulombs is the correct answer. 2 into 10 power minus 6 into 3, 2 into 10 power minus 3, 2 millicoulombs is the correct answer. Our Saimedha Coaching Center under Space Engineering Academy, Space Gate app platform, we are giving AE Genco coaching for EEE engineering students as well as electronic students in both modes, offline modes and online modes. We are giving 40% discount for offline students. If you want to any details queries, just you contact 9848692598 and one more number I am giving 9849713451. And similarly we are giving online coaching also. If you want to take online coaching for both branches, ECE and EEE branches, just 5,900 rupees only, and this is offer up to valid only 10th October 2023. So students, once I am telling, this coaching is compulsory, it is required because the short span of time, where if you want to online coaching, take online coaching. Otherwise, if you want to take coaching offline also, we are giving 40% discount. But students, just because the syllabus is vast syllabus, the duration is very less, that's why without preparation it is very difficult to achieve this goal. So my faculty, as a faculty, I am giving a suggestion, you take coaching either offline and online. For that purpose, our coaching center is giving in both offline mode and online. So everyone it will utilize. Thank you. I wish you all the best.